GMAT all day.
As we continue talking about our absolute value equations and inequalities, let's take a second to mark our progress and see where we are at. So far we have been talking about these simpler absolute value inequalities and equations. And so that means absolute value inequalities or equations where I only have one term that is under my absolute value sign, or I only have a single variable. And because of that, I can easily get rid of my absolute value signs. I can translate this just into two algebraic equations that I can then just solve individually without the absolute value signs. So for these, I can translate these, and for these, I can usually do algebra. Now, as you get into more complex absolute value equations and inequalities, this is going to become harder to do. It is going to become harder to translate, to get rid of your absolute value signs. And that is because, recall, with our simple absolute value translations, we usually had two scenarios. One where the expression under our absolute value sign was greater than 0, and one when it was less than 0. And so now when you have two or more absolute value expressions, or when you have multiple variables, well, now we are talking about four possible scenarios. And so you can have the scenario where this guy is greater than 0, and this guy is greater than 0. Then you can have the one where this guy is greater than 0, but this guy is less than 0. And then you have one where this guy is less than 0, and this guy is also less than 0. And then you have one where this guy is less than 0, but this guy is greater than 0. And so it starts getting very crowded on the page if you're trying to do these with algebra. And in these cases, algebra can start becoming the longer approach, or the more confusing and more complicated approach. So as these get more complex, oftentimes I'm finding myself having to resort to testing numbers, or sometimes I'm doing a combination algebra and testing numbers, or sometimes really I just have to sit there and think about it a bit in my head. So before we get into our more complex absolute value problems, let's take a detour here to talk about testing numbers on the GMAT, particularly testing numbers on data sufficiency questions, because that is where absolute value shows up most commonly. And I think that testing numbers is a very useful skill to have on the GMAT. And when people first start out studying, I see a lot of times that they are testing numbers too much, especially when people take a diagnostic test and they haven't studied it all, and they know that they haven't studied at all. They're basically testing numbers for almost every type of quant question because it is the only thing that they know how to do. However, when people then have started studying and they feel like that they do know some stuff, that is when I see people get into the mindset that testing numbers is the wrong approach, that they should always be trying to do things algebraically, and that if they are testing numbers, then they're doing something wrong, and therefore they become hesitant to do it, and they don't really practice their testing number skills. But in my case, even now, I don't always see the algebraic way of doing something. So if I don't know how to do something algebraically, meaning I cannot translate it, for example, then I sort of have no choice but to test numbers. Other times, testing numbers is quicker. It is the more efficient approach. And lastly, then, sometimes it will be true that you really cannot solve a question algebraically, and testing numbers really is the only way that you can get to the final answer. So I think testing numbers is a very useful skill to have. Really, you want to have multiple ways of doing any question. So testing numbers should always be an option. And I think to limit yourself to only algebra is a mistake. What is even the point of that? Why would you ever want to limit the number of ways that you can do something? So in order to get comfortable testing numbers, you just want to have a framework for doing it so that you can do it in a very deliberate and a very organized way. So this is the framework that I use when I am testing numbers. And again, this is mostly true for data sufficiency. So you can use this framework really for any data sufficiency question, not just absolute value ones. So what I'm trying to do is, I imagine that I am designing an experiment. And so just with any science experiment where you always begin with a hypothesis of some sort, when I'm testing numbers on a data sufficiency question, I am always beginning with the same hypothesis. That is, I am always trying to prove insufficiency. And so down here, if you look at our rules for testing numbers, that is rule number 1. I am always trying to prove insufficiency. So I'm always starting with the hypothesis that this statement is insufficient. Why is that? So here I have 3 outlines of data sufficiency questions, and don't have any statements here because they are not necessary. These are just for illustrative purposes. So you can write in whatever you want. Let's just say that you have some prompt, and we'll start on the left here, that says, what is X? Then I decide that I'm going to try and do this by testing numbers. So I plug in one number, and I get X is equal to 3. And then I plug in some other number for this statement, and I get X is equal to 3 again. Then I plug in some other number, and once again, I get X is equal to 3. So at this point, I have 3 numbers that I tested, and every single one of them gave me X is equal to 3. So I would probably say this is sufficient, and then I would move on to the next statement. But think about what I really did here. I didn't really prove sufficiency. I have not proven that X is always equal to 3. I have just shown that for these 3 examples, I got an answer of X is equal to 3. And technically, in order to prove sufficiency when testing numbers, I would have to have had tested every single possible number, plug in every single possible number, of which there's probably infinite possibilities, and I would have to show that for every single one, they gave me an output of X is equal to 3. And now, of course, that is impossible, and oftentimes it is impossible to prove sufficiency when testing numbers. What is possible, though, is to prove insufficiency, because to prove insufficiency, I only need 2 values. I only need, at a minimum, 2 examples, because once I get a value of X is equal to 3 here on my first example, well, if I can then get a second example of X is equal to 2, well, I have now proven insufficiency because I've come up with 2 different answers to my question, and I have proven it. And so what are the implications of this? So I'm always trying to prove insufficiency, which means I always need, or you always need, when you're testing numbers at least, you need at least 2 cases. And the first case does not matter. This number here, when I got X is equal to 3, this tells me nothing by itself. It is only once I get to the second case that I can infer something. So for the first example that you choose, you should just choose whatever is the easiest possible number you can think of that fits the criteria of the statement. It will give you some number, which will either be sufficient or insufficient. It is the second example that you choose now that matters and that you should put some thought into, because now if you're trying to prove insufficiency, you should be trying to come up with something other than your first result. So something other than X is equal to 3 in this case. So since you're trying to prove insufficiency, that means if you chose a positive integer first, after that you should choose negative numbers. And if you still haven't proven insufficiency, maybe choose positive fractions. And after that, maybe choose negative fractions. And then only if after no matter how hard you try, after trying positive integers, positive fractions, negative fractions, no matter how hard you try, you keep getting values of X is equal to 3, then would I say sufficient. But I'd also remember that I really have not proven sufficiency. I have just sort of failed to prove insufficiency. That is the 4th rule of my framework here. So here, then we said you always need 2 cases. So the first case doesn't matter. Come up with the easiest example possible. And then when you are answering sufficient when testing numbers, really what you were just saying is you were unable to prove insufficiency. So when I am selecting something as sufficient, usually I would say 3 examples is ideal, or if you really have the time, 4 would be great. 2 is less than ideal, but still better than nothing. But 1 example really tells you nothing. You really would have been better off just guessing and saving that time if you can only come up with 1 example. You need to at least get to your second example, or at least have a chance of proving anything. And the last thing to keep in mind is you need to know your criteria when you are trying to prove insufficiency. So let's take a look at a different question. So if instead of saying what is X, our question says, is X equal to 3? So again, if I plug in some number and I get X is equal to 2 for my first output. And then I plug in something else and I get X is equal to 4. Now, if you're still thinking in terms of the first question here, you might say, oh, I have proven insufficiency because I've gotten 2 different values for X. But remember, you have to know your criteria, which means knowing what your question is asking. And our question is asking, is X equal to 3? Therefore, what that means is, in terms of answers, there's really only two options. There are x is equal to 3, then there is everything else. And so you almost can't think of this as being x is equal to 2 and x is equal to 4. This is really just a no to our question. X is not equal to 3, then this here is another no. So even though we have two different values for x, really what we're on the path to here is we're closer to proving sufficiency because we have two outcomes that each gave us a no. So really what we are looking for if we're trying to prove insufficiency is now we are trying to get a yes. And so we're not trying to just get a different value for x. If we already have a no, we are now trying to get an example where x is equal to 3 because that would give us a yes. And so if I'm trying to prove insufficiency, I want to maximize the likelihood of getting a 3 for x. And so let's say that on my third try here, I get x is equal to 3. So I now have a no and a yes to my question. Well, that satisfies my criteria for insufficiency, and I can stop here. I have proven it. But let's say this last example, I had gotten x is equal to 5. That is just another no. Now I have all different values of x, but really this is just further evidence of sufficiency because do not confuse sufficient to say no, which is what this is, with insufficiency. And so at this point, after choosing 3 examples, I would probably stop here and just say this is sufficient to say no to our question. X is not equal to 3. So let's take a look at another example here with an inequality. Is x greater than 2 but less than 10? And so for here, let's say I plug in some number and I get a value of x is equal to 10. With inequality, sometimes you have to think about what happens when you get something that's equal to one of your boundaries. And so here, this is a question that is asking, is x between 2 and 10 non-inclusive? So if x is equal to 10, that is a no to our question because x is not between 2 and 10. So now, if I'm trying to prove insufficiency, I am actively trying to get a number that is now between 2 and 10. So let's say I choose another number and I get x is equal to 11. Well, this is just another no. Once again, I'm on the path to answering sufficient here. And so let's say I choose another number and I get x is equal to 1. Again, all different values for x, but none of them are between 2 and 10. So really, I just have another no here. So let's say I have time to choose one more example and I get x is equal to 4. So now I have a yes to my question. I have proven insufficiency and I can stop. But usually I stop at 3 examples. So let's say I only got to this point. And so if I am choosing sufficient, which I would be in this case, it's only because I sort of failed to prove insufficiency. No matter how hard I tried to get a value that was between 2 and 10, I couldn't do it. And I kept getting no's to my question. Or at some point, you will get a value between 2 and 10, like I did with x is equal to 4. And then you can say, you can stop. You can say you have proven insufficiency. And so this is the framework I use. Remember, you need at least 2 examples, this means, but it also means that the first example does not matter. You can just use the easiest numbers you can think of that still fits the criteria of your statements. Oftentimes, you can use this in combination with algebra, or sometimes, for example, here, if I get x is equal to 3, go back on this first question. So say I get x is equal to 3 on my first example, and then I choose another one, and I get another x is equal to 3. Well, sometimes, even though I've only chosen 2 examples in this case, which is normally less than ideal, but sometimes I can sort of then see the algebra. I can see the reason why 3 is the only outcome possible. And so when that happens, that's just as good as having proven algebraically. And so you can say sufficient at that point. Another reason I think I find this framework helpful is because on data sufficiency, it allows me to reuse information, which is what you want to be doing. Testing numbers can take a long time, especially on data sufficiency. And so, for example, when you are looking at your statements together, you want to reuse as many examples as you can from when you looked at the statements individually. You don't want to have to come up with entirely new sets of examples when you're looking at them together. And this allows me to do that because I can put all of my inputs into a table somewhere. And then when I look at them together, I just need to make sure that I'm only choosing examples that meet the criteria for both statements. And sometimes I can see, oh, I can reuse these two examples. They fit the criteria for both of my statements, and they allow me to see that even together, my statements are still insufficient without doing any real additional work because I'm just using examples I already came up with. So in summary, I think testing numbers is very useful. I definitely do not think of it as the wrong way of doing something. And whenever I can, I try to see how to approach a problem in two different ways. When I'm reviewing that question, if I did it algebraically, I try to do it by testing numbers when reviewing. Then I can choose which way works best for me. And so we will use this framework now in some of the absolute value questions we do coming up.